In this video, we will study the properties of cumulative distribution function. The first property of the cumulative distribution function is that it is always non-decreasing. So that means that if you consider two values x1 and x2, x1 being smaller than x2, then the CDF at point x1 is always smaller than or equal at point x2. So this function will never decrease. If the argument here x increases, the CDF cannot decrease, so it's at least equal to this one. So this is the first property. It is obvious because the event x is smaller than x1 is a subset of x is smaller than or equal x2. The second property is that CDF at point x equal minus infinity is equal to 0. So this property is because we have fx of x, we have x of x is equal to probability of x is smaller than or equal x. This is by definition of CDF. Now, if you put here, if you put minus infinity, okay. Now, if you put instead of x, put minus infinity. So what are the possible outcomes that are smaller than minus infinity? So nothing. So it's going to be probability of the empty set. And obviously this is equal to 0. So asymptotically, the CDF at the margin of from the minus infinity side is 0. So the other side is that if x is plus infinity, so probability that x is smaller than or equal x, okay. Now if this x goes to plus infinity, okay, so this is equal to fx of x. If you put here infinity, okay, so all possible outcomes are smaller than infinity, so this is probability of your L, which is equal to 1. So always the CDF is non-decreasing, it can only increase or remain constant. It starts at minus infinity 0, at plus infinity becomes 1. So what it is means that at this point plus infinity you always have 1 asymptotically, at minus infinity you always have 0, and in between you could have increase or you could have constant, increase or constant. So these two properties mean that. So probability of x being greater than or equal, greater than x is called complementary CDF. So fx of x is called cumulative distribution function, but 1 minus fx of x is complementary CDF, complementary CDF, or complementary cumulative distribution function, because this is probability of x is smaller than or equal x. Now the complement of this event is probability that x is not smaller than x. So if I put a bar here, complement of that is equal to this, and this is probability of, you know that probability of A is always equal to 1 minus probability of A. Okay, so probability of this bar is equal to 1 minus. So this is another property. So the complementary CDF is 1 minus CDF. So the proof is, you can write it this way. Could say that x is smaller than or equal x union x bigger than that, and then the intersection between these two is empty. Probability of their union is sum of the probability, so the probability of this one is 1, probability of this one is CDF fx of x, and plus probability of x bigger than x, so this shall be equal to 1, and from here you could prove this one. The next property is that the cumulative distribution function is always continuous from the right. So if at any point x, if you add a very small number, epsilon positive, and you reduce epsilon to 0, this is always equal to the limit of the CDF from the right, and is always equal to this one. So this is trivial. I'll leave it to you to prove it. And also probability that of this event is always equal to the CDF at this point minus CDF at this point. Remember that here I don't have equality here, here I have equality here. So this is fifth property that you can memorize or learn. Probability that x takes a specific value, remember that this is an event, is always the limit from the right minus limit from the left. Remember that always limit from the right is equal to the value of your CDF. So value of your CDF minus limit. So the amount of the jump. This means that if your CDF is a continuous function, the limit from right and the limit from left, these two guys are equal. So probability of x equal x is equal 0 if there is no discontinuity. If no discontinuity. But if there is a discontinuity, for instance, if your CDF looks like something like that, and then you have something like that, and then you have a jump here. So the amount of this jump is probability that these points happen. Let's say x3. So probability x being equal x3 is equal to amount of this jump. If there is no jump, if your function is continuous, probability of a given point is 0. If you have equality here, you compare property 5 and 6. If you have equality here, so here you put a limit from the left.